AB Calculus Notecard 53, Antiderivatives. This is the 53rd video lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District, who developed this notecard system. Up until now, in calculus, we've been going over differential calculus, finding the derivative of an expression or an equation. Well, here we're looking at antiderivatives, which is going to go in opposite direction. A function f of x, in this case capital F of x, is an antiderivative of a function little f of x if f prime of x, that's big F prime of x, equals f of x for all x in the domain of f. The process of finding an antiderivative is called antidifferentiation, the opposite of differentiation. The family of all antiderivatives of the function f of x is the indefinite integral of f with respect to x, is denoted by this notation here, the integral of little f of x dx. And if we show the relation to big F of x earlier, it would be the same as the integral of big F prime of x dx. And so if you take the derivative of big F and you get f prime of x, that proves that you've had the correct antiderivative. If big F is any function such that big F prime of x equals f of x, then integral of f of x dx equals big F of x plus c is called the general solution, and c is called the constant of integration. So we're going to go over this in our problems we look at. First one, state three functions, f1, f2, and f3, whose derivatives are f of x equals 3x squared. Now sketch all three of your functions on the same point plane and compare these with f of x equals 3x squared. So for this, we're going to say f of x is equal to big F prime of x. Okay? And so the antiderivative of f prime of x is going to be, we'll call it f1 since they're saying 1. So the derivative of what is going to be equal to 3x squared. Because when we find what this is, we know this right here. We know this right here is going to be f prime of x. Then we're going to, what is going to be f1 of x? Well, let's see. In order to take the antiderivative, we're going to have to take, it's going to have to be x to the third power. So let's say ddx of x to the third power. What is that going to be? Well, that's going to be, using the power rule, it's going to be 3x squared. So therefore, f1 equals x cubed is has its derivative equal to 3x squared. So we'll say one of our possibilities is f1 equals x cubed. Next, I'm going to give you another one. And can you think of one? Well, I'll give you another one. We could also take the derivative of x cubed plus any constant. We'll say plus 2. Because if we take, I'm going to go right. The derivative of ddx of x cubed plus 2 is also going to be equal to 3x squared. And so in F3, we can say is equal to x cubed minus 1. Why? Because the derivative with respect to x of x cubed minus 1 is also equal to 3x squared. So all three of these, f1, f2, and f3's derivative, got the answer 3x squared. And so graphing this on a single coordinate plane would look like this. Sketch all three of your functions. So f1 is going to be x cubed, right? So here's x cubed. It's going to be the cubic parent function. The next one we had is f2. I'm going to put this as f1. f2 is going to be the same function, but moved up 2 units. So something like this. And then f3, we'll say it's f2. f3 is going to be this one down here. So we can see, I hope, that the slopes of f1, f2, and f3 are going to be the same no matter where we go vertically here. So let's go on to problem 2. Find a general solution of the differential equation dy dx equals 3x to the negative fourth power. Well, I'm going to go ahead and do this. This is a differential equation, and we have 3x to the negative fourth power. What we're going to do is solve this, and we're going to separate the variables. So we're going to cross multiply the dx. So dx is going to be multiplied right out here in front. So we're going to have dy is equal to 3x to the negative fourth power dx. And when we take the integral of both sides of this, and I'm going to put an integral symbol, the integral of dy is simply y, and then the integral of 3x to the negative fourth, so that's going to be like if f of x equals 3x to the negative fourth, okay, then big F prime of x is equal to 3x to the negative fourth power. So the derivative of question mark is going to be equal to 3x to the negative fourth power. Well, definitely we're going to have we have to raise, so negative third power. So I'm going to say ddx of negative x to negative third power. What is that going to be? Well, we're going to multiply negative 3 times the negative sign and get 3, and then we're going to have x, and we're going to subtract 1 from negative 3 and get negative 4. So that's correct. So y is going to be equal to 3, not 3, we're trying the antiderivative, negative x to the negative 3 power, and we have the constant integration plus c. And then if we rewrite this, we'll have y is equal to negative 1 over x cubed plus c. And we're going to go over the power rules that demonstrate how this works. I want to talk about one more thing. One thing I do with my class, I had them look at consider if a function is like f prime of x is equal to x squared minus 8x plus 15. Okay, the question is, what is going to be f of x? What is going to be f of x? And that's part of finding what the antiderivative is here. Well, what f of x is going to be, it's going to be x cubed over 3 minus 8x squared over 2 plus 15x. And there's also a plus c. Anyway, we're going to examine this with especially the power rule later on. So just hang on. It's going to get easier. We're going to figure out how to do this more in a better organizational style soon. Good luck, and thanks for viewing.